All right, here's some news stories that I thought were interesting. So this one is a material science story, and it takes me back to my days in physics. I did some of this solid-state physics long ago, and so what they've been finding, everyone is trying to find a room temperature superconductor, which would revolutionize many products. You'd be able to make really powerful magnets. You'd be able to lose less power. To have a lot of. But the problem is, superconductors only work at really low temperatures or at really high pressures. And they've found a new category of material that is doing much better. So the current superconductors can't get up to anywhere near room temperature without being under a pressure of like 1,000,000 atmospheres, which means you just have to have a tiny piece of it in a diamond anvil, compressing it with huge pressure. But now they've got a new product made out of a rare earth element I never heard of before, lutetium. I didn't even know this was an element. It's a lutetium. It's the highest, heaviest rare earth in its series. But if you take lutetium hydride and add another element in a small concentration, you create a crystal or a semiconducting structure that actually does have superconductivity at relatively low pressures, more like 10,000 atmospheres instead of 1,000,000 atmospheres. And that's a lot better. And of course, it still doesn't mean you can just have an ordinary wire made out of it, but it's becoming more and more within the range of possibility that you could, if you improve this thing some more, so it's a big step forward. And one of the amazing things about this is you can see physically what it looks like. This is the actual stuff. It's this green lump of this material, sort of like a metal. And then when you put it under pressure, at 3 kilobars, it turns pink, which is 3,000 atmospheres, and up to 32 kilobars, it continues superconducting at room temperature, all from 3 to 32 kilobars. And at 32 kilobars, it undergoes another phase transition and turns bright red and is not superconducting anymore. So you have to take the original stuff, which is blue, and squeeze it enough to turn it pink. And then it will superconduct, and if you squeeze it too much, it turns red, and it doesn't superconduct anymore. But this is sounding more doable. These are not insane pressures. You could imagine building some kind of gadget that traps the wire under pressure. I can see you could squeeze it down with some kind of stiff plastic or something, maybe hit these pressures. It's beginning to seem like you might be able to actually make a reasonable device that could exploit the superconductivity out of this stuff, especially if they manage to find variants of it that are even more productive. So that's something to look forward to. Veeam is an online backup service. Whatever it is, it's a product. I've heard of it. It's a Veeam application service, and this is actually very nice, especially if you're taking 129S, where we're talking about API security and web app security. What they did was they have a cloud backup system. And you put it on your servers, or I think it's on your servers, it might be on theirs, but it runs a service. The Veeam backup service runs on TCP port 9401. And this service is used to communicate between your instances of Veeam, if you have many of them, to synchronize the backups across many servers. But it also lets you make a request. You can request the encrypted credentials, and it will deliver them to you without any authentication to get them. So this sounds like a really serious flaw. And it might be fair to call this an API flaw. You can make a request, API flaw, you can make a request for a secret, and it honors that request without checking your authentication first. So you can get credentials without authentication, and then you can use the credentials to take over the system. This is really serious. And so you have to merge to the next version, and if you can't do that, then you're going to have to block this at the firewall, so people outside your company can't come in. But if you do that, then you're not going to be able to synchronize your multi-instances if you have a multi-instance deployment of it. So it is a pretty serious problem for people that are using this Veeam product. This one, I was just talking about on Pulse Security Weekly. It is a sort of mathematical cryptography discovery. What these guys did is, if you are sending some apparently random data, like a long series of text created by an AI or just random noise, then you can embed a second message in it, and you can do it by some system called maximum entropy coupling, or perhaps minimum entropy coupling. But anyway, they have a way you can have a private key, which you tell someone at the other end, and you can use the private key to embed extra data inside that signal, which is steganography. You have a second message hidden in the first, and it is completely undetectable. See, there are no statistical measurements you can make on the stream containing extra data that will come out different than a stream not containing extra data. So this is a sort of, in a limited sense, this is a secure form of cryptography, and there may be ways to build products that exploit this. What they're doing in Florida is pretty extreme, but I thought this was a very nice article in the New York Times. I think I put it on my links with as gifted to anybody, even if you don't subscribe to the New York Times. I thought this was really quite sensible and balanced. And what's happening in Florida is Ron DeSantis is trying to stop what the right-wingers consider to be liberal indoctrination in colleges. And as they say, that's why I thought this is very good. My other people who teach at like big fancy universities tell me it really is out of hand. The political correctness required at colleges is really extreme, and you get fired for very innocent things, and everybody is terrified, and many people don't dare to speak their mind anymore, which kind of contradicts the whole point of colleges. You're not allowed to have any politically unpopular opinions. And so there is some truth to what the right-wingers say, that the colleges do not have a diversity of opinion and do not allow free speech and exchange of ideas, which is kind of their point. But of course, the problem is DeSantis is trying to cure this by simply mandating what you can say. He's now censoring the textbooks, censoring the curriculum, censoring the classes you can teach, removing any class that he decides is woke. So here's, people have published things like diversity education, diversity, inclusion, and equity and inclusion classes can erode academic freedom. So I guess the point is, if the left tries to control what happens in colleges, and they've done it clumsily, so it has a negative effect, now the right is moving in, trying to control what happens at colleges, and their intrusion is also having a negative effect. So I thought it was a very fair article to read about, and the kind of stuff we have to think about. This goes on forever, that people try to politically control what goes on at colleges. So Noam Chomsky, the famous activist, is also a famous linguist. His actual scientific discipline is linguistics, and he therefore is very qualified to analyze ChatGPT. ChatGPT is one of the new AI models that is hitting the news everywhere, and what it is basically autocomplete. Autocomplete, if you're writing an email or a text message, it will suggest what the next word is by just looking at some database and deciding what the more common next word might be. And ChatGPT just does that in a more sophisticated way, so it can write whole pages of stuff. You can give it a question in the form of a few sentences, and it can then give you like a page of output as a reply. And it looks pretty good, like a human wrote it. But it has serious flaws, like ChatGPT is perfectly happy to write fiction and fantasy and give you the wrong answer if it gets the impression that that's what you want, because it doesn't understand the truth of anything. And this is the point of what he explains here. It looks like a human wrote it. It looks like a human understands what's going on, so people will be fooled into using this for important things, connecting it to real physical devices or weapons or something, and thinking it actually understands that it should only shoot the bad guys and not the good guys and things like that. And he said, you have to understand, people think this is awesome and it's going to replace a lot of humans at work. And Noam Chomsky says all that is not going to happen. People are not understanding how very stupid these AI models are and how they are not in any way doing what humans do. Because what humans do is they actually understand concepts. And then they try to express that in language. And they understand that one statement might be true and one statement might be false, but they understand the concept. They actually live. They know that I have the ball is in my hand. If I drop the ball, it will fall. It will fall because there's some force called gravity. And if there wasn't any gravity, then it wouldn't fall. Humans do reasoning like that. And ChatGPT doesn't do that at all. It's just ordering the words to make them look like other words it's seen. It has no idea what they mean. It has no logic to it. It doesn't understand what it's saying or what it's doing. It's just creating something which, at a cursory inspection, looks like a human made it. So anyway, yeah, that's a fair statement. Anyway, so I thought this is a very nice analysis. That's right. Well, Noam Chomsky did some work, quite a lot of work in linguistics in among all his political stuff. Anyway, all right, this is kind of entertaining. These people got married in the metaverse. in the Taco Bell metaverse know yet. I didn't know this. Apparently, someplace down in Silicon Valley, there is a super Taco Bell, a luxurious Taco Bell that is considered a great place to be. And they built a special Taco Bell metaverse, and these people got married in the Taco Bell metaverse. So anyway, if you're one of the very tiny number of people that care about the metaverse, there is some stuff still happening in the metaverse, although Meta seems to have very quietly pulled back from the metaverse and instead switched to AI as their development focus. And so here's, as everybody is starting to use these AI engines for everything, there's a security flaw that people don't understand. This is the way any new technology is. People don't understand what the risks of it are. And what people are doing is taking ChatGPT, which is an online free version of this AI tool you can use. So you can ask it a question and it will give you an answer. And so people are doing things like uploading our whole business plan as like a PDF and say, make PowerPoint slides out of this. Or uploading an article and then saying, summarize this article. And so it can do that. And it can do it pretty well, but the problem is it's learning from every input you put in. So if you upload something confidential, like your company's business plan, it will remember that. And somebody can come by later and it might repeat phrases from that. And if you're clever enough to hack it by carefully asking questions, you can get it to dump out an entire document it's memorized as part of its learning process. So it's kind of like using a public computer or a public Xerox machine, where if you put private things on it, then people that come after you might recover those private things you put on it. And people, of course, don't understand that because it's new. So his doctor input his patient's name and medical condition into the ChatGPT and asked it to write a letter to the insurance company. And that is the kind of task that ChatGPT would be good for, but in that case, you should have it running in a private cloud on your own servers, not the public version that other people can use after it's absorbed your private data. And okay. This one is awesome. I just talked about this on Pulse Security Weekly. This is incredible. So the elliptic curve digital signature algorithm is what's used in the Bitcoin blockchain, and it's what we're all recommended to use now instead of RSA signatures, which are the old one. It's cheaper and faster and in general a better cryptographic system because RSA has some flaws that are hard to avoid, and elliptic curve cryptography is not supposed to have those flaws, but it turns out that it does have a disturbing flaw. When you calculate a digital signature, you have to add a nonce to it, a number used only once. And if you do multiple signatures with the same private key, which is what you would do on the Bitcoin blockchain if you have several transactions out of your wallet, then it has to use a different nonce every time you do it. And that, if you have a really random nonce, everything would be fine. But a lot of people write this, they don't understand the nonce should be random. So sometimes they use the same nonce more than once, which is really bad, or they use nonces in a simple pattern because they just take like a default random number generator from some language like Java or something, and the default random number is not very random. It's a linear congruential generator, so in a sense, the numbers are just sequential. And so you can predict them. If you have two of them, you can predict the next one. And it turns out that if those numbers are related in a simple mathematical way, then and you sign this, make several signatures with the same private key, you can mathematically extract the private key from the signatures by solving the equation that connects the nonces, and you can extract the private key. And they did this in a real Bitcoin blockchain. These guys attacked the Bitcoin blockchain to see what they could do, and they extracted something like 700 private keys from the Bitcoin blockchain by running a cloud server with 128 or 256 GPUs for a couple of days and spending a few $100s to run that machine. That's all the amount of calculation it took. And they were actually able to break into over 700 Bitcoin accounts because, and this is the simplest case, those are ones that actually use the same nonce multiple times. So really poorly written software. And they found that all those wallets were empty because somebody else already figured this out and already stole the money, many millions of dollars. And so it's very interesting, and this would apply to anybody that uses ECDSA. Anybody that's written any code creating these signatures should really consider whether they used a really good random number generator to create the nonce. Because if you used a less secure random number generator, then you might have a hole in your software, hole in your security, which is not obvious at all. All right, and Europe Their tech bills are coming out, so theoretically the internet will get safer. I think this is a bit extreme, but certainly the internet should become safer because Europe has passed several bills. They're way ahead of the United States on privacy. And so big services like Google and Wikipedia and YouTube are going to have to change what they do because of the Digital Markets Act and the Digital Services Act, which are now in effect in Europe. And the result is they consider your business and see how big it is. And if you're a really big business, very large online platform or very large search engine like those ones I mentioned, then you have strict standards of transparency and regulation. So you are going to have to make security models explaining the risks and explaining how you moderate them and having external audits to make sure that you have moderated those risks. And you're going to have transparency where you explain what you do with the data you collect and so on. So this may really improve security in major ways. And we'll see how it works out in practice. All right, let me stop this recording.